So, Assalamualaikum. Hi, my name is Muhammad Zuljalal bin Musa. My metric number 281944. Today, I will show you step by step question 1, and I hope you can understand what I'm trying to present to all of you today. Thank you. To integrate the integral from 0 to 3 of xx multiplied 2x squared plus 3 dx with respect to x, first of all, bring out the factor 8 to the left and multiply the rest, and you will get 2x to the power of 4 plus 3x dx. In order to substitute x with u, we shall assume u equals to 3x. Therefore, x equals to 1 over 3u, and so dx equals to 1 over 3 du. Let's make those two x and dx value as substitute 1 and 2. Now, to get the new interval, we shall find the value of u when x equals to 0, which is 0 as well, and to find the second interval, substitute x equals to 3, and you will get u equals to 9. Hence, the new interval in terms of function u is 0 to 9. Now that we have the new interval and the function in u, substitute 1 and 2 into the function, and you will get such as this. You can see on the screen. Now again, bring out the factor 1 over 3 and multiply with 8, and you will get 8 over 3 integrate 0 to 9. 2 over 81u to the power of 4 plus u du. Then substitute u equals to 9 in the function and then minus it with substitute u equals to 0 with the second function. Complete the calculations and you will eventually get the answer 885.6.
Hi everyone, my name is Tan Xingyi and my matrix number is 278700. The question 2 is given Q equal to 700 minus 2P plus 0.02Y, where P equal to 25 and Y equal to 5000. Question 2a is find the price elasticity of demand. By using the partial derivative, we can know how much quantity demand will change by 1% change in price. The partial derivative means its derivative with respect to one of those variables, with the others held constant. And we use it times P over Q in order to find the price elasticity of demand. This also is a formula that we use to find the price elasticity of demand. It can be written as delta Q over delta P times P over Q. Due to this, we need to find the quantity first. So we substitute the P and Y that given by question 2 into Q function. Q equal to 700 minus 2 times 25 plus 0.02 times 5000 equal to 750. Then we substitute the value of quantity into the formula price elasticity of demand. For the partial derivatives delta Q over delta P, we have found that is negative 2. We use negative 2 times 25 and divide by 750. And we got the answer is negative 0.067. Therefore, it means that 1% change in price leads to a negative 0.067% change in quantity demand. Next, question 2b is find the income elasticity of demand. Same with the price elasticity of demand. For the income elasticity of demand, we also use the partial derivative because we want to know how much the quantity demand will change by 1% change in income. And we use it times y over q in order to find the income elasticity of demand. It can be written as delta q over delta y times y over q. Since we already have the value of q, p, and y, so we just substitute these values into the formula income elasticity of demand. For the partial derivative delta q over delta y, we have found that is 0.02. We use 0.02 times 5,000 and divide by 750. And we got the answer is 0.133. Therefore, it means that 1% change in income leads to a 0.133% change in quantity demand. That's all for me. I will pass to the next presenter.
Okay, next I will present question 3. In this question, I need to find the critical value and determine the point at function f(x,y) equals to 3x cubed plus 1.5y squared minus 18xy plus 17 is at relative maximum, relative minimum, inflection point, or saddle point. Alright. First of all, we would like to discuss about how to find critical value. Okay, the first step that we need to do for finding critical value is set the first order partial derivative equals to 0. The first derivative for f prime x is 9x squared minus 18y. When this function equals to 0, we will get y equals to 1 over 2x squared. And the first derivative for f prime y is 3y minus 18x equals to 0. And after we solve it, we will get y equals to 6x. The second step is setting y equals to 6x, which is 1 over 2x squared equals to 6x. Then solve it and we will get x squared minus 12x equals to 0. From this equation, we can get the critical point for x is 0 and 12. And the third step, we can put both the critical point of x, which is 0 and 12, into the equation y equals to 6x. So, when x equals to 0, then y is equals to 0. And if x equals to 12, then y is equals to 72. Now, we can conclude that the critical point are 0, 0 and 12, 72. Next, I will move to the second instruction, which determine if the point that we get from the function is at relative maximum, relative minimum, inflection point, or saddle point. Firstly, we need to take the second order partial derivative. So, for the second derivative of a function fs is equals to 18x. And the second derivative of a function fy is equals to 3. Now, we put the critical point we get, which are 0, 0 into d, and we'll get negative 324. This means saddle point 0, 0 since d is less than 0. And then put 1272 into d, and we'll get 324. That means this is relative minimum since d is more than 0 and fss is more than 0. After that, to get inflection point, we need to let second derivative of s equals to 0 and we will get s equals to 0. So we can conclude that inflection point is at x equals to 0.
Assalamualaikum warahmatullahi wabarakatuh. My name is Alif Aiman bin Aziz. My metric number is 278296. I will continue our presentation about assignment 3. The question is the number of question is I get is question 4 is minimize the cost function c equal 5x squared plus 30x plus y squared minus 32y subject to the constraint x plus y larger than or equal to 20. Next, the problem can be rewritten as minimize c xy equal 5x square plus 30x plus y square minus 32y, subject to equal x plus y larger than or equal to 20. Second step is setting the Lagrangian function. It is c x y equal 5x square plus 30x plus y square minus 32y plus the lambda open bracket 2 minus x minus y close the bracket. The second step is setting the Kuhn-Tucker condition. First is differentiate the C with respect to X and Y and Lagrange. First, we can get x open bracket 10x minus 30 minus 80 minus the Lagrange equal to 0. Next, we can get the c respect with y. We can get y open bracket y 2y minus 32 minus the Lagrange equal to 0. Next, we can get the Lagrange respect with the Lagrange. C respect to the Lagrange. It means Lagrange open bracket 2 minus x minus y equal to 0. That means we must to multiply this. We must to differentiate this function to get the Kuhn-Tucker condition. The second step is testing the Kuhn-Tucker condition. Assume the Lagrange equal to 0. From the equation 1, it is 10x minus 80 larger than or equal to 0. We can get 10x equal to 80. That means x equal to larger 8. It means x equal to 8. Next is from the equation 2. It is 2y minus 32 larger than or equal to 0. We can get 2y minus 2y equal to 32. That means y larger to 16. That means y equal to 16. Next step is substitute x equal to 8, y equal to 16 into the constant equation. The constant equation is x plus y larger than or equal to 20. We can get this 8 plus 16 equal to 24. That means the 24 is larger than or equal to 20. It is satisfied with x plus y larger than or equal to 20. Next is assume the x equal to 0, x equal to 20, y equal to 0. We can get x larger to 0. Next, assume y equal to 20, x equal to 0. We can get y larger to 0. This means x larger to 0, y larger to 0. For the next slide is with x equal to 8, y equal to 16 and Lagrange equal to 0. This is the optimal function. Thus, with Lagrange is equal to 0, it can be concluded that the constraints are non-binding and the firm can minimize the cost by exceeding the production quota. we can get the minimum value of the cost function. The cost function is c equal 5x squared plus 30x plus y squared minus 32y. That means it is mean x equal to 8, y equal to 16. We must substitute this s and y. We can get the minimized function is 576. That's all for me. Uh, that's all for me. Thank you.
Good day, my name is Hao Jiayan and my metric number is 278515 and I will present the solution of question 5. Question 5 needs us to optimize the functions by using the Cramer rules for the first order conditions and Hessians for the second order conditions. To solve the first part of question 5, which is the first order conditions, we need to do the first derivative for the variable x1, x2 and x3. To the first derivative, we will get the derivative functions of variable x1, x2 and x3. To apply the Cramer rules, we need to rewrite the functions in this form. Next, we need to write the function in matrix forms and right-hand side variables of the functions as the solution vector. Then, we need to find the determinant of the matrix A by computing the matrix A, and the determinant of matrix A is 4, 4, 8, and the determinant will be used to find the values of x. To find the value of variable x1, x2 and x3, we need to compute the 1 over determinant together with the matrix A by substitute the solution vector into each column. For example, to find the variable x1, we need to sub the solution vector into the first column of matrix A and sort it together with 1 over determinant. We will get the x1 value equals to 23 over 56. To find the variable x2, we need to sub the solution vector into second column of matrix A and sort it together with 1 over determinant. We will get the x2 value equals to 25 over 28. For the variable x3, we need to sub the solution vector into third column of matrix A and sort it together with 1 over determinant, and we will get the x3 value equals to negative 1 over 56. For the second order condition by using Hessian, we need to find the second derivative of the function. Through the function in part A, the second derivative of the function x1, x2 and x3 are as shown above. Then, we need to use the answer of second derivative to rewrite it as a matrix form, which as a matrix hash. Then, we need to compute it and find the determinant of matrix hash, which is 4, 4, 8. In conclusion, we get the result of h1 equals to 6, h2 equals to 71, and h3 equals to 448, which is the determinant are greater than 0. So we can conclude that the function is positive definite and minimized at the critical value of x's. That's all from me. Thank you.